All right, here we go. Now, the application of this comes from this, that again, this is not in your textbook. This is technically year 11. But I find it that is extremely important that we see this first, so it's not this time wasted in year 11 for your teacher in year 11 to go back. So you already have a foundation very strong on polynomials. And no matter what polynomials comes to you, you know how to break that polynomial down. So you find those factors or you can graph that polynomial. So let's go a little bit of a recap of what we did last class. I'm going to do a quick recap. And when we spoke about long division, we, of polynomials, of course, we said that in order to give the answer, I'm going to say, well, the dividend in function of x, right, equals to what? The divisor, which is in function of x as well, times my quotient, all of these things are in function of x, plus my remainder, right? And again, all of these things are in function of x. Now, this again is basically the layout that we do when we write down my final answer of my polynomial being divided by a linear factor. Now I'm going to write this down differently, and please see the similarities, but now in a mathematical language. I can also say P of x, right, equals my divisor. Now, my divisor, what type of factor is that? Is that quadratic factor, linear factor, cubic factor? What is it? The divisor. Normally, what the divisor is. It's a linear factor. So I can just say that is x minus a. Do you agree with that? Yes? It's like x minus 2, x plus 1, whatever it is, times my quotient. Like my quotient is any function, right? Whatever the solution of that quotient is. It could be a quadratic, it could be a cubic, whatever. Like I'm actually bringing the degree down because technically that's what we do. From a cubic, my solution of my quotient would be a quadratic, right? From a quadratic is a linear. So I'm going just to stick with the language of my quotient as a q function. So I'm going to call it, this will be q of x, right? And my remainder, well, is the solution. I'm going to call it r of x, whatever value I get as my remainder. Now, I want you to pay attention to this because I'm going to go back to an exercise that we did in the class, in our last class. That, let me see if I can just get it out very quick here. One of the exercises that we did, which was this one. I'm going to write it down here. My P of x was x squared plus 4x plus 1, right? And my divisor of my other function, I divide this by, I'm just going to just divide by division, like my divisor, which is x minus 1, right? Go back to your notes and tell me what was the remainder of that. This was the first example that we did in division. Tell me what was the remainder of this. What was it? 6, right? Now, remember, we did all these steps, like leading term divided by the leading term of the divisor and all that stuff. But look at the beauty of this. Guys, please hear this out. Because if I do this, you are going to go straight into the answer. Now, x minus 1, right, is a linear factor, right? Now, I'm going to substitute P of 1 in my um, normal equation, in my normal p of x, right? I'm going to substitute p of 1. Now, where is p of 1? Now, if this is x minus a, right? If it's written like that, minus 1, technically was originally written as x minus plus 1. You'll agree with that? So that a value is plus 1, right? It's like when we used to do like the translation horizontally, we'd read that as the opposite value, right? So my a value here is plus 1. So if I evaluate my original function, p of x, by that p of a, look what's going to happen. So 1 to the power of 2 plus 4 times 1 plus 1. What's that? That is 1 plus 4 plus 1, which is 6. Do you see that? So what was that value? What is 6 here in my, if when I evaluate 1? What is that? The remainder. So you can go directly to your function by evaluating the value of a of your linear factor into your original equation or into your p of x and find out what would be your remainder. And that will give you an idea like, did I do it right? Did I miss something? Is my division correct or not? Now, this is super important. This is what we call the remainder factor theorem that says this. I just need to like get it here. So, P of A, sorry. The remainder factor theorem says this. The remainder says this. If a polynomial P of X is divided by X minus A, right? If I got a polynomial divided by X minus A, the remainder is P of A. P of A. Like, I'm going to evaluate A. Does that make sense? So technically what I did here is P of A equals my remainder. Let's do an example and see how this applies for different scenarios. So find the remainder of P of X. So I got this cubic function, x minus 8x squared plus 9x plus 18. And they say find the remainder when is divided by x plus 3, x minus 3, and x plus 1. All right. So I've got 3 linear factors that they have given me, and I'm going to find out what will be the remainder of these 3 when it's x plus 3, x minus 3, and x plus 1. All right. So just stay with me, and then you will do one later. If I need to find out the remainder for my first value, so I'm going to just put here what happens when it's x plus 3. Which one is my a? Which one is my a? If it's x plus 3, what is the value of a? It's negative 3. It's the opposite, right? Another way to do it is just take the x plus 3, equal that to 0, and then you know that that value of a is minus 3, right? Why is it negative? Because remember, it's written as x minus a. That is how, so in order to get minus a, so that should have been x minus sorry, x minus minus a. And because the writing of this is plus, right? So this is x plus a technically. So originally was a minus. So if that is the case, I'm going to evaluate minus 3, right? I'm going to see what will be the remainder of my function when it is divided by a linear factor of x plus 3. So let's do it. So that would be minus 3 to the power of 3 minus 8. Now, guys, please, I encourage you with the brackets, particularly when you have a negative value, that if it's raised to a power, it's all of it with the negative, all right? Do not write this. Please don't do this. Don't do it without the bracket. If you do it with like that, most likely only takes account on this value and doesn't do anything with the negative. Now, with the cube one, it doesn't really matter, but when it's a square one, it really matters. So let's evaluate this. What is minus 3 to the power of 3? What is it? Negative 27 minus, now, 9 times 3, which is, like a times 9. Yep. And I can just do this. 9 times 3 is minus 8 minus 27 plus 18. What is the solution of this? Negative 27 minus negative 72 minus 27 plus 18. It's like an addition at the start and then a subtraction of 18. Negative 108. All right. That is the remainder of dividing. If I do, now I'm just going to make a parallel of this. If I do x plus 3 of x cubed minus ax squared plus 9x plus 18. If I do the solution of that, my remainder will be, it's like when I keep going down this, tick, 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 I will end up with negative 108, right? I will get something here. I don't know what. I'm interested at this stage about the remainder. Now, this helps you to really, like, if they ask you, do the long division of these two polynomials, divide this longer polynomial by this linear, and then you need to know if you did it right. The way that you did it right is just confirming that your remainder has to be this one, and when you go down this path, it gave you the same remainder. That's how you know that everything is in the same kind of like correct order. Does that make sense? How to find the remainder by substituting that a value, by looking at that linear factor that we have found or is being given. We go directly into the function to find out what will be the remainder of my solution. Let's do the next example. Let's say if I have x minus 3. Which one is my a value here? Sorry? It will be positive 3. Again, it's always the opposite. So here, what I will do is p of 3. Again, 3 cubed minus 8, 3 squared plus 9 times 3 plus 18. Solution. 27 take away 72 plus 27 plus 18. So equals 0. Did you all get 0 on that one? Now, I'm going to put a start on this one because this is going to be super important. What happens when my remainder is 0? All right, so hold on that. Let's do the next one. X plus 1. Is it plus 1? Yep. What is my a value? Negative 1. So p of negative 1 is negative 1 cubed minus 8, negative 1 squared plus 9, negative 1 plus 18. Solution. minus 3 minus 8 mi- minus 1 plus 18. What's that? Is it? Is another 0. Okay. Now, those zeros are super important. All right. I'm just going to highlight them. And I'm going to highlight also this, because they are going to mean something regarding a cubic function. The one that denote zeros, they don't really mean anything, all right? But when the remainder is 0, it has a purpose. It has something meaningful for our solution at the end of our cubic function. I'm going to go into the reason why with the title. The factor theorem. Now, the factor theorem has something very important about it. It says if P of A equals 0, remember, where does the A come from? Where does that A comes from? Yeah, from that linear factor that I'm dividing by, right? I'm dividing my P of X by that linear factor, which is that A value that I gathered from that. I evaluate my original function, and then I find the remainder. If P of A equals to 0, then X minus A is a factor of P of X. What does that mean? What does that mean that it's a factor of P of X? What is the meaning of a factor in this case? What does that mean about when it says is a factor of P of X? There's no remainder. It means that that value is like, if you look at in long division, is like, is the exact value that divides the exact whole number with a remainder, right? Which means that that becomes, guys, this linear factor in my cubic, quartic, whatever I'm dividing by, this one becomes either an x-intercept or again a factor of that cubic function. Does that make sense? Yeah. This, what I'm trying to say, this one is divides the P of X with no remainder. I'm going to show you an example for you to understand what that means. Can we please do this? This is my P of X. Is x cubed minus x squared plus 9x plus 18. And I'm going to divide by x plus 1, right? Now I'm going to ask you to do the division. Please divide it. So do x plus 1 divide x cubed minus ax squared. I want you to do the division, but before you do the division, tell me what is P of A? So what is P of negative 1? Tell me what that is first. Before you do the long division, tell me what is P of negative 1. Sorry? It's minus 1 to the power of 3 minus 8. Yep, correct. It is 0, which now we can say that x plus 1 is a factor of p of x. All right? Now, guys, x plus 1 is a factor of p of x. Okay? Now, can we do the long division now, please? I need you to do it. Solve it. I'll give you 2 minutes for that. Now, notice what I'm going to do to solve it, please. Stay with me. Start asking yourself many questions. Which ones are your leading terms in both the divisor and the dividend? So do your division. All right. Now, x squared times x plus 1, which is x cubed plus x squared. Write that down underneath that and subtraction. So that cancels out. What is minus 8 minus 1? Minus 9. Bring the plus 9. Then what do we do here? Is minus 9x over x, which is minus 9x. And minus 9x times x plus 1, which is minus 9x squared minus 9. And that also minus. So minus 9 minus minus 9, that will be 0. And 9 minus minus 9, what's that? 18 positive x. Bring the 18. And again, identify the leading one of that one. 18x divided by x, which is 18. So plus 18. And then 18 times x plus 1, which is 18x plus 18. And that is a subtraction. And we got 0. Did you get that? So far, so good. Now, let's write down our final answer, which is x cubed minus 8x squared plus 9x plus 18 equals to what? Tell me what that equals to. X plus 1. What else? X squared minus 9x plus 18 plus 0. So don't worry about writing down the 0, right? Now, here is the part that I wanted to go and see the purpose of doing long division and breaking down and then dividing it by a factor of this p of x that it's 0 here. That will give me a factor that is part of this cube. And now I got this what? What is this function? Quadratic. We know how to solve the quadratic. How do we solve it? It's a monic, so it's finding multiples of 18 or factors of 18 that also add up to minus 9. So remember, we got x plus 1, and then we have 2 more factors here, right? X and x. What are the multiples that add to 18 and also, multiplied 18 and add to minus 9? Negative 3 and negative 6. Good job. Negative 6 times negative 8, negative 3 is positive 18. And negative 6 plus negative 3 is negative 9. This is technically, remember, this is p of x. So notice that this is the factor form. There are, how many linear factors do I have? 3. And we know how to graph this. So how many intercepts do I see? 3. So notice that guys, and if you evaluate, if I do P of 6 and P of 3, what do you think will be the remainder of these two new factors? What do you think it would be? Correct, because they are factors of P of X. Remember, a remainder is that when I divide it by divide P of X, we know remainder. When I divide the factors, P of X will be 0. The remainder will be 0. So let's do the graph. Here, this is the whole purpose of this. Where are my x-intercepts? In -1, +6, and so 3, 6, -1. What else do I need to do? Y-intercepts. Now the y-intercept, you can either evaluate it directly from P of X, or you can do it here. They aren't exactly the same thing. This is just written in an expanded form, and this is in a factor form, right? So I can just say is 0 plus 1, 0 minus 6, 0 minus 3, which is 1 times minus 6 times minus 3, which is 18. So again, 0, wait, what? So somewhere here is 18. Now, guys, always the question. Now, look at this. You got two forms of writing P of X. Is this one and that one, right? Now, please, everyone, pay attention here. Look at the board for a second. Just look at the board. If I need to draw this, there are things that I need to look at, which is my leading term, which is the coefficient of the leading term, basically. Which one is A here in this P of X? Which one is A? Sorry? It is 1. So I always look at A. I can look at it from here, but I like looking at here because I've got the function written in the general form. This is written as ax cubed, right? But there is no value of A, which means that A is what? Is 1 and is positive, right? According to the rule, what happens when the value of A is positive? Where do I start? Below the axis or above the axis? Below the axis, right? And I'm going to go through every point, right? Again, I don't care about the turning points at this stage. So you can draw it as the way that you want. You can just do this, cut here. It needs to cut in the 18, right? Come down. You need to go down to get up to 3 and then go back up. And that's it. That is the whole purpose of dividing. And I want you to notice something. When I divide it by a linear factor, I reduce the degree of my function to a quadratic to find the other two. Does that make sense? That is the whole thing. Now, sometimes these two could be the same. It could be a repeated one, which means that then the graph will do something like this, right? Depends on what the shape of the graph is. Depends on these factors. That will give you the whole solution. Are there any questions so far about what is the intention and the purpose of writing down our cubic and then doing all this division thing? Sorry? It means that x minus or plus a is not a factor. Is not. When I'm saying factors, it means that most likely will cut the x-intercept. It will cut the x-intercept, right? If it has a remainder, it's nothing. It's just a point in the graph. All right. Now, things get tricky when they don't give you a linear factor to start with. I'm going to give you an example. So they will say this: factorize p of x, and they give you this. This is a typical question in a test. Factorize 3x cubed plus 11x squared minus 6x minus 8. All right? How would you start this? Because again, factorizing, we already learned that I can divide by linear factors and then potentially apply quadratics and find the other two. Do I have a linear factor here? Are they telling me divide by something? So, because they're not saying anything, I know exactly what I need to do. I need to find factors of this polynomial, right? That the remainder is 0, right? Now, this part is the annoying part of this whole thing, is trial and error, which means that you are going to find values that your remainder will be 0, and then you will start from there. Let's start. Evaluate, like you are going to ask yourself, I'm going to evaluate values from 0, yeah? I'm going to evaluate values of 1, 2, right? But I could go, so you will be like, say, but there are infinite numbers. Yes, I agree with you, but I'm not going to be so like mean to give you crazy values so you can evaluate. Like the idea is that you always start with 0, at least the first two positive values, but also they could be negative, right? So I can also do -1 and -2. So let's do that, right? Let's evaluate my function based on those values to find out which one gives me a remainder of 0. And then from that point, I start doing my division to factorize that cubic function. Does that make sense? So which one will be the easiest to start with? I will do 0, p of 0. So that will be 3, 0 plus 11, 0 minus 6, 0 minus 8. But that already you know what's the answer of that. Is that a factor? Yes or no? That doesn't work. So 0 doesn't work. That means that the graph doesn't cut through 0. Does that make sense? Let's do p of 1. All right, we got 3 plus 11 minus 6 minus 8. I need your expertise here. 3 plus 11 minus 6 minus 8. Calculate us if that's still evaluated. So to know if that is a factor, yes or no. Is that a 0? Is 14 minus 14, which is 0. There you go. We found a first factor. So what is the factor in this case? How do I write it down? X minus 1. Good job. All right. Now, because I already found my factor, I'm not going to keep finding more. I could find the other two by keep trying and error it, like, but the best way of doing it here is just doing the long division. Now, another thing that I wanted to say is, I can't remember what I was going to say, but anyways, let's divide now my oh, I remember. X cubed, right? I'm dividing by a linear factor. I'm going to expect my solution to have then an x squared, a quadratic, right? Now, because it's a cubic function, we said that it could potentially have 1 intercept, 2, or 3, right? So you still need to think about, like, this is not just the only solution. There are potentially other 2 solutions, and the way that you find out is literally solving the whole question. So now you're going to say, well, x minus 1 divided by 3x cubed 11x squared minus 6x minus 8. Go for it. Solve that because you guys are expert now. All right. That should have been your solution. P of x is x minus 1, 3x squared plus 14 plus 8. Now, it's a little bit ugly. How do we solve that quadratic? Is it non-monic? Can you solve it, please? Yep, no one likes non-monics. Solve that non-monic. You need to do it. I'm not gonna do it this time. All right. Remember how to do non-monics. This has to be from the top of your head. The other one is already done. X minus 1. So then that would be 3x squared. How can I write down 14? Finding the two factors that add up to 24. B over 2 square. But that's something else. That's something else. 12 times 2. Now, x minus 1. Now, what do we do with this? Just it's grouping. So that would be 3x factor of what? X plus 4. Yep. And then 2x plus 4. So that would be x minus 1, 3x. Yep. Look at this. Guys, look at that. P of x is x minus 1, 3x plus 2, and x plus 4. Again, all of those must give me a remainder of what? Of 0, right? Thank you, Ashwin. Let's, how many intercepts am I expected to see now? 3 because they are all 3 linear. So let's do that. So I got 1 in positive 1. Now, to find the other ones again, you just equal those factors to 0 because one of those has to be equal to 0. So x minus 1, and for that one would be x equals 1. 3x plus 2. What is my x-intercept on that one? Nope. If that's 3x plus 2, what is the x-intercept? Negative 2 over 3. X plus 4, x minus. So I got minus 4 and minus 2 on 3. What is my y-intercept? We've already done it, which is negative 8. So P of 0, which is negative 8. No, positive 8. Yep. Again, is it from the bottom starting or from the top starting? Above the axis or below the axis? Below. What is the value of my A here? What's the value of A? Sorry? Oh, it's negative 8. Yeah. No, you're right. I was looking at a different number. I was looking at the quadratic. Now, again, I ask you, do I start from the bottom axis, x-axis, or from the top? With the bottom, why from the bottom? Okay, look at my cubic function. My cubic function, the value of A is 3. Is the one that accompanies the leading term, which is the one that determines, again, how to write my graph. So I will do this. Go up, go down. I'm going to go and cut in -8 and then go back. All right. Say that again. How does it determine? It doesn't. At this stage, it's not important. I'm like, it starts from the bottom. Doesn't matter. Why? Because of the value of A is positive. This value determines as well the shape of the graph. All right. When we look at transformations at a sphere, that value of A determines again, is it below or above the axis? Guys, basically this is it. This is all about cubic functions. And this is what I'm going to ask you on Friday. I'm going to give you, guys, hear me out. I'm going to give you a cubic function and I'm going to ask you two things. I'm going to ask you to evaluate, I'm going to ask you to divide this by this linear factor, and then I'm going to say factorize this cubic function. All right? That's all. And those are the things that you need to be able to understand. Yet the quiz is going to be only two questions. All right. At the end of the day, it's the same thing. What I want you to learn from here is: did you know how to do long division? Did you know how to graph? All right. So I want you to just like have an idea that I can probably ask three questions. Two, one you have to graph. One, then you just have to do the long division. That's all. All right. I want to see that you use the remainder factor theorem, that you use the remainder theorem and also the factor theorem to think about these factors of P of X. Yep. Yeah, similar like I did here. Because guys, this girls on that side, this is super important because look what the question says. It says factorize P of X. It doesn't say anything else, which means that you need to say, well, I'm going to evaluate values and evaluate values that you know, 0, 1. And guys, this can get more complex. Like for example, if you look at my factors here, my other factor is A being -2 and 3, right? But that gets too complex just by going into this trial and error. That's why you can find as many as you can, but then you can get caught up with a fraction. And we like finding that fraction is quite impossible because there are infinite numbers from fractions to whole numbers. So that's why once you find one, stop there and solve the cubic function, right? That's how you do these questions. All right. Let me see what else. I think that's it for. I'm gonna give you some questions for you to practice. All right.